We're in business. We're recording example A here from our 5.2 worksheet. And you're doing this on the back. To do 8 to the x equals 4. What I want you to try with these is to turn this equation into an exponential equation. Can you turn 4 into a base to a power? And can you turn that 8 into a base to a power? And can the bases be the same? So can this little 8 become something to a power? We still have the x up there. And can this 4 become something to a power? And the key is to have these two somethings, these two somethings be the same base. Can you turn 8 and 4 into powers of 2? Can you do that? What would 8 be as a power of 2? What? 8 is 2 to the third. So I rewrote this red 8 as this red 2 to the third. The x is still out there. And can you rewrite this red 4 as 2 to the something? 2 to the second. And now we're in business. Because we have two bases that are the same on either side of the equation. Now we're going to incorporate some of those properties that we talked about in the last 5 minutes. If you have a base to a power, what can you do with those powers? You can multiply them. So on the left side of the equation, let's rewrite it as 2 to the 3 times x. And on the right side, we still have 2 squared. We have a base to a power equaling a base to a power, and those bases are the same. Well, let's go back a page, and let's take a look at this example. Ooh, there it is, down at the bottom. This property down at the bottom, the common base property. It says, if a to the n equals a to the m, then n and m have to be equal. That definitely applies with what we're doing now. If anything to the n equals anything to the m, then m and n have to be the same, and that's where we're going with this. We have 2 to a power equaling 2 to a power. So what's true about their powers? They're equal. Set the powers equal, drop out the bases, we're almost there. If 3x equals 2, what does x equal? 2/3. Now on your calculator, type 8 to the 2/3 power. If it says 4, you did it right. If you just do 8 to the 2/3 and you don't put parentheses around the exponent, it's going to do 8 squared, which is 64, and then it's going to divide by 3. So to do 8 to the 2/3 power, to check your work here, you want to do it like this. Your calculator will say 4, and you'll say, yay, and you move on to the next problem. All right? So let's try it. Let's clear the ink off this page and do example B. Example B says 27 to the x equals 1 over 81. So I want you to take 27 and 81 and write them both as powers of 3. They're both powers of 3.
I don't get how,
27 to the x. Rewrite that as a power of 3. 3 to the what? 3 to 3? Yeah. 3 to the third is 27. Still got that x up there. That's supposed to equal 1 over 81. Can somebody write 81 as a power of 3? 3 to the power of 4. Now it's still in the denominator. So there's going to be a couple steps here to try to get this to line up right. Remember, in the last one we had 2 to the 3x equals 2 to the 2. And since they were both 2 to the something, we could set them equal. On the left side, On the left side, we have 3 to the 3x. And on the right, what do you have? 1 over 3 to the 4th. I need to write that as 3 to the something. Yes, 3 to the negative 4. And now we're in business. Now we're in business because since the bases are the same, this is the a to the m equals a to the n. Therefore, who's equal? Their what? Their exponents are equal. If their bases are equal, then their exponents are equal. So the next line is to knock out the bases and just call it 3x equals negative 4. Divide both sides by 3. X equals negative 4/3. We've solved for x. We've solved for the exponent using logic. So in this final problem, in this example, they give us 49 over 9 to the x equals 3 over 7 to the 3/2. So we need to look at how we can look at these two bases. 49 over 9 and 3 over 7, and see if there are any numbers that are sort of in the same family of powers. When I talk about families of powers, I'm talking about 3, for example. 3, and then 3 squared is 9, times 3 is 27, 27 times 3 is 81, and so on. These are the numbers in the powers of 3 family. 7, then 7 squared is 49. Aha, I think we're already there. We don't even need to go to the next level because 9 is right here, and that's part of the 3 family. And 49 is right here, and 49 is part of the 7 family. So the 49 I'm going to rewrite as a power of 7, 7 squared. The 9 I'm going to rewrite as a power of 3, 3 squared. I still have the parentheses with the x outside, the parentheses with the 3/2 outside. Inside here, I still have my 3 over 7 with the 3 on top and the 7 on the bottom. And that's pretty significant because the 3 is on top and the 7 is on the bottom on the right side. But on the left side, they're flipped. The 7 is on top and the 3 is on the bottom. So I'm going to fix that in the next line as I proceed. I'm going to move on to one color here. And we have 7 squared and 3 squared as part of a fraction. One of our properties is to take that common exponent and pull it out as the main exponent. 7 over 3 to the 2, and then the x will still be multiplied by it. That's the power to the power rule. On the right side, I wish this 3 over 7 was flipped upside down. I want the 7 on top and the 3 on the bottom so that red would match with red and green would match with green. To get that 3 over 7 to become 7 over 3, it's very easy. You just make its exponent negative, and that'll get it to flip. Now, as you can see, we have the same base, 7/3 and 7/3, to a power. So what you can do is ignore that common base, and bring the exponents down. 2x must equal negative 3/2. The last step is to simply divide both sides by 2, and you get x equals negative 3/4. This concludes the 3 examples from section 5.2, Properties of Exponents.